Hello and welcome to section 3, Keras, making Theano even easier to use. In the previous section, we saw how to train a simple model with Theano. We saw that all that we need is to define expressions, shared variables, and modify these shared variables in place to minimize the cost. We do that using compiled functions and updates. In this section, we are going to take a look at Keras behind the scenes, fully connected or dense layers, and convolutional and pooling layers. Let's start with Keras behind the scenes. In this video, we will look at how Keras defines neural network models. How does it connect multiple layers? And we will see where in Keras a model is compiled and trained. To motivate our quest through Keras, we go back to the MNIST classification. This time, let's define a multi-layer perceptron. Like this one, a 2-hidden layer neural network. Let's go to Keras source on GitHub and start by learning what this sequential means. Here on Keras source code, we start by going to the folder Keras, models, and we look for a class sequential. By definition, we know that sequential is both a model and a containers.sequential. Let's understand this containers.sequential first. Containers.sequential is inside Keras, layers, containers.py. Let us understand what the method add from sequential do. Here's the add method. Remember that we keep doing model.add and then a layer definition? So yeah, let us understand what it does. Containers.sequential simply creates a list with all the layers we added. Also, all the layers in Keras have this setPrevious method. This is how the getInput function knows the layer input expression. I set expression to remember that all these operations are symbolic and represented in Theano or TensorFlow, depending on your backend. No actual numbers are calculated when defining a Theano expression. We only get them when calling a compiled function. So this is containers.sequential. Let's go back to the models.sequential. This is an important method, compile. We call it after adding all the necessary layers to our model. The method gets an optimizer and a loss function as parameters. If they are strings, Keras will look at a list of valid predefined functions. Down here, inside the compile method, we see how the model gets the total inputs and outputs of the network. In here, we can see that the desired signal is expected to be of the same shape as the output of the network. This is to make sure they can be compared. A few lines later, still inside compile, these two lines calculate the cost function for training and test. Sometimes they are calculated differently, especially when using regularization such as dropout. There is another pair of important lines in compile that I want to talk about, which is the definition of updates. We are giving a list of parameters and the cost function to the optimizer class, and it returns the updates to optimize the parameters. Check optimizer.py for more details. Finally, the compile method finishes compiling the functions themselves to output the cost function and update the weights. Note how the test functions don't have updates. This is to avoid optimizing the model on the held out test dataset. For the Theano backend case, k.function simply calls theano.function. After we call model.compile, we want to train our model, and we do that using fit. Fit is also pretty straightforward. The method will get inputs x and desired values y. That size is the number of rows or samples from the dataset that the model sees at a time. Number of epochs is how many passes through the entire dataset will the method do before stop training. This fit method will call the compiled_train function and update the parameters, using our passed input-output pairs as input. Fit can also receive a validation data and report performance on a held out dataset. Usually, when the method keeps improving on the training dataset but doing poorly on the validation dataset, it means it is overfitting. This is why it is interesting to pass a validation data to the fit method. This ends our video. In here, we saw how Keras automated the Theano pipeline to write symbolic expressions and compile functions with updates to optimize values in place. In the next video, we will understand how fully connected or dense layers work.